Hello everyone. In this session, I'm going to cover a topic called numerical control (NC) system. This NC system, nothing but a numerical control system, numerical control system is a part of CAM system, CAM, computer aided manufacturing. Now, the name itself indicates the complete system is controlled with the help of numerics, nothing but numbers, and followed by symbols. The complete system is controlled, means the manufacture is performed automatically with the help of a numerical control system. Now here, this particular system is controlled by numbers, letters and symbols. Thus in simple definition can be written as it is a programmable automation. Now NC system is, let me change the color so that you'll understand better. Here NC system, we can call it as it is a automation programmable automation in which the process is controlled by numbers, letters and symbols. Now what are the numbers, what are the symbols or letters, how those are communicated with the machine, how the information is passed on to the machine to do the specific work, that all I'm going to discuss in the upcoming lectures. As this is a introductory part of NC system, a simple thing you try to remember that it is a programmable automation. With the help of numbers, letters and symbols, we can easily control the machine to perform a specific task. By using these, we can control the machine to perform a specific task. Okay, what is the task? Nothing but manufacturing. Maybe it could be turning operation, maybe a drilling operation. Okay, and other applications are also there. Those all I'm going to discuss in this session. All right, now here a numerical control system or technology has been applied to wide variety of operations. What are the different operations where this NC system is applied? That also I'm trying to discuss here. The different operations I would like to mention here are maybe it includes, this particular thing is included in, it includes in drafting, this includes in drafting and assembly, and also inspection or sheet metal working, or you can say inspection. In these ways, or else you can call it as the next one is spot welding. Means by using the information which I have given you before, numbers, letters and symbols, we can we can position the tool, or we can position the complete process wherever the location you want to position it or place it. Okay, so for example, at some point a spot welding is required. I can, without manually, with some automation, what I can do, I can position the tool at that particular point by using the NC control system. So few applications that you can remember is this includes spot welding, inspection and metalworking, assembly, drafting. Okay, all these ways this can be used. Okay, now what are the basic elements which will actually help the complete NC system to work properly? What are the basic elements? There are three basic elements which you need to remember. There are three basic elements one should remember. Three basic NC system elements. Okay, or these elements can also be called as components. Okay, so students should remember, one, the terminology is more important. whenever a question is given on the basic elements or basic components, one and the same. All right. The first one is program of instructions. Program of instructions. Okay. Program of instruction. Let me increase the thickness of the pen so that it look better on the screen, so that you understand better. Number two is control unit. Control unit, or as you can call it as controller. All right. And nothing but the name itself indicates it will control the complete machine. Okay. Which we can, the third one is machine tool. The ultimate aim of any system, any manufacturing system, is fabricating or manufacturing a component. So if that is the case, machine tool is the actual machine where the component is produced. Manually, if you look at manually, if I want to operate the machine, we need to have an operator, followed by there should be a material handler who get the material and fix it on the machine, and the technical person, nothing but the operator, will start working on it. And again, one more material handler who will, what he will do is he will try to unload the machine. Means material handler will do loading and unloading, both will be done by the material handler only. So manually, when you work on machines, more manpower is required. Again, one more person is required to take the completed products to the sub assembly zone. Okay, so there are many people involved. When you use a numerical control system, you can avoid such multiple persons involving in the same work. Means this complete machine tool is controlled with the help of a controller. What does a controller will do? Controller will take the information from the program of instructions. Controller will take the information from the program of instructions. All right, then it will read the information properly and it will interpret the information. Means it will try to interpret the complete information, and that information is passed on to the machine tool. Machine tool will work and do its task accordingly. Okay, this is a simple explanation about three basic elements or components of any ANSYS system. All right, so let me explain each one: program of instructions, control unit, and machine tool, step by step. All right, let me discuss about the first point, which is called program of instructions, or else let me move aside and then I explain you so that it would be better clear. All right, now have a look. Let me discuss the first point, which I have mentioned you already. Number one, program of instructions. The name itself indicates instructions. I can instruct the machine with the help of numbers, with the help of letters, with the help of symbols. That is what I have discussed from the beginning. So how it is going to be done? Means the detailed step by step set of directions will be given by using a punch tape. I just can say it as step by step instructions. Okay, step by step instructions are given. Okay, which tell the machine tool what to do, how to do. Okay, and where exactly, where to do on the workpiece. Okay, for example, there is a simple component or a metal piece where a drilling is need to be performed at this point. So this is the origin, means the tool is going to be placed at this position first. Maybe let us imagine or assume. So the tool need to travel in some units in x direction, some units in y direction to reach this point. For example, this is the tool's position after x and y. So these instructions or informations about how to travel in a specified direction is given by program of instructions with the help of numbers, letters, and symbols. This is what I mean. Okay, so it is coded in numerical or symbolic form. Uh, so this input medium that can be interpreted by the control unit. For example, just let me draw a simple sketch here. For example, I'm going to give these instructions in the form of a punch tape. Let me take a tape. Let me draw it a bit bigger. Let me erase this line. Let me draw first how exactly the complete three elements look like. Okay, let me consider this as the punch tape. Punch tape is like a tape, generalized tape only. Okay, on this tape instructions are given. Now let me change the color. Maybe instructions for your understanding. Some instructions are given with some numbers, symbols and letters. All right, so this information is passed on. This information is passed on to the controller. This is how this I call it as program of instructions. Then there will be a control unit. This is how the control unit is going to be. Simple sketch, try to understand. Okay, there are two rollers on which the tape will be rolled and information will be read and interpreted. This is how the tape will be rolled. Whatever the tape prepared with symbols, numbers and letters, that will be passed on to the controller. This we call it as a controller unit or control unit. All right, the information is read and interpreted and that information is passed on to the machine tool. How you represent a machine tool? The machine tool is represented something like this. You find in many technical mechanical textbooks. This is how it is represented. Machine tool is represented. So all the three are interlinked. So whatever the information is punched on the punch tape, this we call it as a punch tape. Punched tape. And under this particular controller you have a tape reader. Tape reader. So this tape reader will read the information properly which is there on the punch tape, because directly the program of instructions can't be read by the machine tool, which is not at all possible. So this is going to communicate properly with the machine tool by passing the information. Nothing but the controller will act as the bridge between the machine tool and the punch tape. All right, this I am calling it as a machine tool. Okay, we can call it as machine control unit also. Now this controller I can call it as MCU. Remember this terminology, machine control unit. All right, this is how it is going to be performed. The common input medium is, now as I said, this punch tape is made of 1 inch. Okay, punch tape. Two methods of input to the ANSYS system. Okay, there are two ways where you can pass on information to the ANSYS system. One is manual entry. The information can be entered manually. Okay, manually, or the same information can be passed by using the manual data input, or else it can be used by direct numerical control. The information can be passed manually, or else by using the direct numerical control. Now coming to the methods of passing information to the machine tool. Manual entry of instructions are one, where data can be controlled by the control unit, and is called manual data input. This is called manual data input. All right, and one more is input by means of direct link. Okay, direct link. For example, this is the first one. Second one is input with the help of a direct link. What is this direct link means? That link with a computer. This is called a direct numerical control, DNC. Okay, by using DNC also instructions can be passed on to the machine tool directly without any manual data input. Okay, This is how the program of instructions are passed from first level to the till the machine tool. Okay, the job of a programmer. What is the job of a programmer here in this case of three elements is to provide a set of detailed instructions by which the sequence of processing steps uh, involved, where the relative movement between the cutting tool and the workpiece should be proper. Okay, what is the uh, for example job of a programmer's job. Let me change the color. The main job of a programmer is to have a relative movement between the cutting tool and the workpiece. This is the main thing. How he can communicate between those two, or how he can maintain the relative movement means how he or she can maintain his relative movement means by using the sequence of processing steps, by using sequence of processing steps. Okay, this is how the complete program of instructions will work out. Now the second one, out of three elements, this is about the first one, and the coming back to the second one, it is all about uh, control unit. Control unit. This is the second element in NC system. NC system. Okay, if you get a question based on NC element, explanation is more important rather than providing all the three elements. Okay, what is the program of instruction, what is a control unit, what is the basic principle or working principle of control unit, and machine tool, how does it work, how it takes the information from the control unit, how it will work, all the information you have to provide. Now coming to the control unit, it consists of, what does a control unit consist of? Because this will take the input from program of instructions, and that it will read properly, it will understand nothing but it will interpret the data, then it will pass on to the machine tool the way machine tool will understand the language. Okay, for that case the complete control unit, whatever I have drawn before, for example this is how the control unit look like, as I mentioned before. Okay, there will be tape rolled over the rollers. Okay, which will pass, tape will be passed from one side to the other. Okay, that instructions are given to the machine tool. This is how I have, this is what I have discussed. Okay, so what does the control unit consist of? It consists of electronics. It consists of electronics and hardware, complete hardware. Consists of electronics and hardware, and which will help to read and interpret the data. This electronics and hardware will help to read the data and interpret the data. Okay, this is what you need to remember from the control unit. Okay, which data it is going to read? Whatever the data come from program of instructions. Okay, whatever the data punched on the tape, which is of 1 inch. Okay, which is of 1 inch. Whatever the data punched, how the data is punched again, that I'm nothing but I'm revising whatever the data I have given you before. Like the data is given in the form of numbers, letters and symbols. Okay, so the same information it will read, it will interpret and pass on to the machine tool. Machine tool will start functioning, it will convert the mechanical action to machine tool. Okay, it will convert the mechanical, let me change the color, the machine tool here, it will convert mechanical actions to machine tool. Okay, this is what happens. Okay, now the whatever the elements of conventional control unit include, the how it now what are it will include means there will be a As I mentioned before, let me list out. There will be a tape reader and a data buffer, means storage. Data storage is also available, and signals output channel, signal output channel to the machine tool, or there will be a feedback channel, or you can say unit. Okay, so all these are the elements of a control unit, where it will read the information by using these many elements. It will read by using a tape reader, and whatever it will read, the information is going in the data buffer, okay, for assistance. And the signal output channel will be there. Whatever is stored here, with the help of the output signal channel, the information is passed on to the machine tool. Then again, you have a feedback controller. If something goes wrong, with the help of whatever the program of instructions we use, that will be sent back to the feedback unit, where you can read and you can see whatever the mistakes made or errors made on the program of instructions. Okay, uh, and this is how the overall operations. This is how the overall operations are performed. Okay, overall operations are performed. In brief, this is what we can this steps you need to remember, or the elements of control unit you need to remember. Now, the complete ANSYS system with a microcomputer as the controller unit is called the computer numerical control. For example, here we are discussing about NC system in this lecture. Okay, the same complete NC system with all the three elements, the complete NC system with a microcontroller, or let me say the microcomputer, means if we attach a microcomputer to the complete three elements as a controller unit, then the same system is called as computer numerical control. This is the only difference between those two. When you add a microcontroller, when you integrate the microcontroller to the machine tool, definitely the program of instructions can be given in the form of G and M codes. Okay, so where you can easily eliminate these punch tape, 1-inch punch tape, where you punch the information in the form of numbers, symbols, and letters, and that is given to the controller to read and interpret the data for the machine tool. All this can be avoided by using computer numerical control system, just by integrating a microcontroller to the machine tool. Okay, now coming to this particular, specifically if you talk about a tape reader, uh, it is a electromechanical device for winding and reading the punch tape containing the program of instructions. Okay, this will have a complete electromechanical device, which will uh, for reading, then this is used to read the information. All right, the data contained on the tape are read into data buffer. Whatever the data we read, or this particular tape reader reads, that will go into the data buffer, which stores the input instructions in a logical block of information. This will store the information in the form of a logical block. Okay, so initially whatever the raw data comes to the controller will not be read by the, or will not be understand by the machine tool. That will be read by the tape reader with the help of electromechanical devices, and that information is saved in the form of input to the in the data buffer in the form of logical block of informations. And other than this, the third element is machine tool. The third one, let me move this a bit. increase the thickness. Now the third element of ANSYS system is machine tool. We have discussed first two. Coming to the third one, it is a part of ANSYS system which performs a useful work, nothing but it will manufacture the component. Final stage, useful work, which is nothing but the manufacturing at the final stage. The ultimate aim of any manufacturing system or a production system or a CAM system is to manufacture the component with utmost accuracy or precision without any dimensional changes or aesthetic appearance of the model. So that is done by using a machine tool. Okay, machine tool consists of what are all the elements does this particular machine tool consists of? Means it consists of a work table. It consists of a work table. There will be a spindle, as well as there are motors and controllers. All these are elements of a machine tool. Okay, there will be a motor where a motor will help you to pass on the power required, movement required in directions, and spindle to rotate in clockwise and counterclockwise rotation by catching hold of the workpiece, and a work table will be there. Okay, obviously other than the machine control unit there are controllers inbuilt in the machine tool. Okay, this is how the component machine tool, again I'll just try to redraw the representation of a machine tool. This is how it is represented mechanically. This is the work table, this is the location of a spindle where the tool will be placed, here the work will be placed, and the movement accordingly takes place. Okay, this is how a machine tool is represented. Okay, this is all for this particular lecture, where I have completed what is ANSYS system, followed by it is a part of CAM process, and it has basically three elements. One is program of instructions, number two is a control unit which we call it as machine control unit, and there will be a machine tool, and in depth I have given the complete information about all the things. Try to remember technically the terminology which I have used to write any descriptive part of your exam. Okay, if you find any difficulty or if you want to ask any questions related to the topic, you can comment in the box given below. Thank you for now.